Welcome back to Graphing Polynomials, Part 2. And what I'm going to do is I'm going to show you how, even without a graphing calculator, I can do a pretty good job at producing a graph of some kind of polynomial. So what I'm going to do is an example here. And let's see here. Maybe I'll clear off the entire grid here before I start, or sorry, the screen. So clear that off, even though I didn't write much. And I'm going to pull up the grid, and so I'm going to try and keep as much of it visible for you here, or sorry, visible for you on the screen. So here's what we're going to try and graph. So here is the question. We've got a nice little third degree polynomial. So I go, yeah, there it is, x cubed plus 2x squared minus 5x minus 6. So that's what I'm going to attempt to do a reasonable graph of. And the only really accurate way to do it is to rework this into the factored form. And so we're going to use all the tricks that we would have done before, whereas you take a look at the number at the end and you go, oh yeah, those are my contenders. So I'm going to plug in plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, until I find a factor. Then I'm going to keep going and keep working it until I finally get a factored version of it. Now, to save time, I just went ahead and did that. So here's our factored polynomial. Remember, it's the same polynomial, it's just looking a little different. It's just factored. Okay? And remember that f of x here can be thought of as y. So what I can really do now, once it's in the factored form, is I can spot a whole bunch of very useful points that I'm going to use for graphing. So really, all we're talking about here is you really want to think of what you're doing as just getting points in a table of values. But these are really key points, like, for example, if I pick x is 2, well, that's going to make 0 and make the whole thing 0. It's one of my x-intercepts. Same thing with negative 3. And same thing with negative 1. So those are some really key points. I mean, look what it does. It kind of frames my whole graph in. I got 2, 0, I got negative 3, 0, and I got negative 1, 0. I mean, there's kind of, key ingredients on the graph. Another easy to grab point would be, why don't we just throw in an x value of 0, which would be 0, 0, 0, negative 6. Hey, there's the the y-intercept. Okay, so 0, negative 2, 4, 6. There it is, another point on the graph. Keep in mind that what a graphing calculator does is it just plots tons and tons of these points and creates an accurate picture. And what we're trying to do is kind of the same thing, but we're being smart about it. We're trying to graph key points that really help us frame in the picture. Okay, the other thing that I need to do is say, well, this is a third degree polynomial, and it has a positive x cubed. So the basic shape of this thing is this. Okay, that's the basic shape of the graph. All right, and that's something you want to be able to just remember. So now I'm going to go over here and see how that would fit. Well, that means this part here must be coming from down here somewhere. Okay, so this is kind of roaring up. Then I do a little loop-de-loop. Now I'm not sure how high to go on my loop-de-loop, but I know once I get back to here, I'm going to go speeding down here like this. I got to hit this point. Then I don't know what I'm really doing here. Do I do a big loop around? Do I, right away go back up? That's where it's very difficult to tell accurately. And then when I get to here, I guess I'm back up, heading off, up to positive infinity. So, I kind of got a large part of my graph worked out. Now, how do I finish it? How do I fill in these little blanks here? There's no easy way at this stage. All you can do is say, well, how about we take a little look when x is negative 2? And how about over here, the one point that I didn't look at is when x is 1. Okay, and that should complete the job. If I plug -2 in, and you can go right back to the original function, I don't know if the factored one is any faster. I went ahead and did this, and I got a y value of 4. So that tells me -2 is up at 4. Okay. And when I plugged in 1, I got -8. So 1 is down at -8. So way down there. All right. There's no way to know without using a graphing calculator if this is the high point or not. Sort of would make sense if it is, but I actually checked and I don't think it was. It was very, very close though. Close enough for what we're doing here. And then I'm going to complete this little loop down here. And you know what? This actually isn't the lowest point, but that, again, for what we're doing here, whoops, see if I can fix that a bit. Do a better job of this guy. Whoops. It's not easy. Okay, let's try and... That's why I don't teach art. Alright, I got a bit of a kink in this thing here. Smooth it out with just more color. There we go. Just fill that in. Alright, there it is. Absolute perfection. And there it is. There's a rough idea of the graph. It's pretty close. It is not perfect. This little location over here is pretty close to what we call the local maximum. Now what that means is, in this location, in its neighborhood, in its locale, it is the highest point, the maximum. Similarly, down here, this is very close to what we call the local minimum. Now, the only way to get these absolutely certain without using more advanced mathematics, at this stage of the game, the only way to know for sure is to actually use a graphing calculator, and we won't be pursuing that. We're going to say this is close enough, and we like it that way. So that's where I'm going to stop for now, and we're going to come back